How have you been doing? So, so hello everyone. Can you hear me clearly? Hey Harish, hey Rumen, Karthikeyan, Abhishek, Manish, and okay. So almost everybody is able to hear me. Good, good, good. All right then. Let's start. So before we start, we continue our discussion on Zookeeper. Do you have any questions? Just for the context, we were talking about a service called Zookeeper, which basically provides you a way to coordinate with other services, and it's basically a central whiteboard or central kind of a place where you write and the others read from there. All right, so it's a very strongly consistent, and it provides you mechanisms for for coordinating with other nodes, and those mechanisms include creating nodes, reading from nodes, basically something called nodes, essentially to store data. And this is for storing a smaller piece of data. It's not for storing too much of data. And so a central place where you can read write data from. And the data is organized in the form of nodes. Nodes can be normal nodes, and nodes are exactly like a tree nodes where each node has some value. You can put some value at the node, and each node can have more nodes at the child. Nodes have the access controls. Nodes have the access controls so that various processes do not interfere with each other. Also, there are many different kind of nodes: sequential node and ephemeral nodes. Ephemeral nodes disappear as soon as the client disconnects, and the sequential node are automatically create their full name with a random number, not random number, a sequential number. Okay, the way we had given an example here. So, so do you have any question till now? Okay, so no questions, and no questions is not a good sign. Either you understood everything, or I skimmed through a lot of things and you did not grab it. Okay, so recording is on. All right. Now carrying on. So is sequential node clear to you? Okay. Okay. So we were going through something called let me just increase the font. Okay. All right. So the way we were, you can also open this Zookeeper client and let's see what is the status. Okay, so it's up. So somebody has created Jungle Book. So if you can see in this, when we say ls slash is a command of Zookeeper. It's not a Unix command. Right now we are on the Zookeeper prompt. So we are talking to Zookeeper. When we say ls slash, we said give us the nodes at the top level. And these are the nodes at the top level, right? And you can see that Zookeeper itself keeps a node called Zookeeper and there is a quota. Similarly, you have these are the other some of these nodes are created by students only. All right. Now here you can see there is something called HBase unsecure. So it's created by HBase. Okay. For coordinating with um, HBase region servers and HBase master. Okay. So that's a real live example on what's the point of learning this. Okay. A real example of who uses it. Not really. Not really. It's not unsecure. It is just that we have not secured it. That's why HBase has created unsecure folder. If you go to HBase and specify various kinds of security properties as well as the enable the ACL as in access control lists onto Zookeeper, then this will get secured. All right. HBase has given it as a name as unsecure. But right now it's unsecure. If you see, I mean, I being a student, okay, though the HBase is being run by root, I'm able to access everything. So the minor information, I mean, information that is required to coordinate between all of these parties, we use Zookeeper. Okay. In future, people are planning, I mean, to move HDFS also towards Zookeeper so that HDFS and Datanode can coordinate with each other using Zookeeper, and probably they have already done it, right? And similarly, the other services also they are trying to port themselves to the Zookeeper. Okay, so the use case is clear to you. Why do we need it and who uses it? All right. Now we created these nodes yesterday, and we call it slash 6 December. Right? So these were the sequential nodes we created. The sequence number, the max running number, is stored in the parent node in which the sequence nodes are being created. So each parent node keeps its own running number for for the sequential nodes. Okay, it starts with 0 and keeps on moving. So if we say create minus sequential node and we say 6 December and we provide some prefix like X, now can somebody guess what will be the node that gets created? So here I'm saying create minus S. I'm providing the prefix of the node name. This is a parent and this is a prefix. Okay. So automatically a new node with a new name will be created whose prefix will be X, and the and the running number will be appended to this. Okay. So what should be the name of the node that gets created? Quickly. No, actually it will be 11 because 6th December the current running number is 10, right? So oh, current running number was something else. It was already created and we probably dropped it. Okay, you can see that. All right. So it keeps increasing every time. So you can see 13, 14, 15, 16 and so on. And looks like the number 11, oh there is 11 number, it's not delete, it's not this there. And yeah, all right. So does that make sense to you? That was created yesterday. Yeah, that was created yesterday. Awesome. Good. So yeah. So most of the service you will be designing, if in case you get into any distributed computing product development. So if you are designing a master slave kind of system and you have multiple nodes, you will be using you will be using Zookeeper to make sure the coordination goes well as you can use Zookeeper elsewhere. For example, you are building a MapReduce service. Say you are writing MapReduce code. Okay. In the map or in the reduce, I mean, mainly it would be in the map. If you want to have the coordination between running mapper or running reducer, then you could use Zookeeper as well. All right. Since most of the Zookeeper service is highly available, it won't get impacted too much if there are many mappers talking to the Zookeeper. It's just that your mapper will get slowed, right? So this can work as a coordination services elsewhere also. Good. Now there is something called watches. So every time we from the API, in case we want to get notified, every time we every time something happens, we want to get notified, we can create watches. Okay. So we can tell that when the node is created, give me a notification. When a node is deleted, when a node is changed, when children are created onto a node, we want to get notified. So those are called watches. And also, you can only get the watches once. Say when if you are listening to the modification on a node, you will only get the notification once. I mean, the first modification. After that, you won't get the modification. For that, what you have to do is in this for the first modification, when your are getting launched, triggers will be creating another watch so that it gets notified again on the next edit, and that will keep on going. Okay, triggers will have to re-register for the watches. So that's the kind of watches we're talking about. And these are the basic commands. We talked about create mainly, and then there is a command called delete. We can delete a particular node. Say, for example, we just created. Okay, so let's just see what happens. So right now we have this node. Okay, in this node, if we say delete 6th December, and the one that is maximum is probably the 16th. Okay. All right. Now, if you create another sequential node, it should be 17. It won't create. Yeah, good. Then there is a command called exists. Okay, so exists, and we say, why don't we have? All right, so probably the exists is what we call ls. Right, right. So exist is equal to ls over here. Exist in the term of if you're talking in using API. Get ACL, set ACL is for seeing the access controls. Get children is to get the children of a node, and get data. Here we use a command called get, but in case you're talking through a program API, you will be using get. You'll be using get data in case you're using the API. All right. Sync is synchronizes a client view of Znode with Zookeeper. Okay. In case you are in case you are having I mean in case you are having a little bit delay in your node getting refreshed, you can use the sync. All right. So the other there are minor additions to the API, such as since all of the transactions like create, update, delete, all of these commands are transactional when it comes to Zookeeper. They are fairly safe. Okay. So similarly, it provides you a multi update in which you can bunch all of these commands together and then execute. Either all of them will succeed or nothing will succeed. Okay, so that's a kind of ability Zookeeper provides you. Either all fail or succeed in entirety, and effectively it tries to provide you the transactions. Okay, it provides you the transactions, and the and the inconsistent states. What does it mean by inconsistent state? If there are three commands, say create, update, and then update again, so the end user will not see the, I mean, the other clients, other clients of the Zookeeper who are observing the particular node or anything, they will not see the state in between. Okay, so multi update, I need to see how can I bunch them together, because it doesn't give you. Okay, okay, all right. So Malik's question is that can we show us an example of multi update, and the command line does not provide you, so I might have to prepare an example in a programming language like Java or something. Okay, this command line doesn't provide you with the. Okay, so never mind. So I'll update with a simple project demonstrating you the multi update one. Let me make a note of it. Okay, so if you're talking, because as I told you that you might use Zookeeper to coordinate between your MapReduce jobs, and in case you have to do that, you will have to use the API to talk to the Zookeeper. Okay, so there are multiple APIs provided by Zookeeper. The core API is in Java and the C. Core API is done by the core founding team, while the contributed API is in various languages like Perl, Python, and there is even a REST-based API. But most important part of the design of the API, probably this is something you can also learn here, is every function has got two kinds of fingerprint. Every function, okay, has got two kinds of fingerprint. So first is your normal one, sync kind of thing, where you make a call to a function, and this function execution will wait. I mean, the next instruction to exist command will not be executed unless exist finishes. All right. So unless exist returns something, it won't go to the next step. So whenever there is a sync command, it has to return something, or if it has to give out something, it has to return. While the other form is async. Async is what? You execute something and then you provide a handler saying that once you finish execution, you run my command. All right, you run my command. Most of the event observers, most of the way we handle the event is done using async manner, that when this node gets deleted, inform us. Okay, instead of saying delete it now and I'll wait till you delete, we say that delete it, and whenever you're done deleting, do this. Okay, run this function. So that's a kind of async manner, and there is a sync manner. Okay, so async manner makes it possible to run things in parallel, so that so that the client is not blocked until the work is finished. But async provides the added complexity to the client, because doing a storyboarding as in first this finishes, then this is that kind of storyboarding is difficult when there is a async call. Async means asynchronous and sync means synchronous. Okay, so almost every function has got two signatures, not almost all the functions. Okay, and so you can see that function and then arguments, and then it throws something and then it returns something. Okay, same the fingerprint of the same function is in the form function, then those same arguments, and then callback, and then there is an object which is a context which we are passing. Okay, we pass the context so that whenever the function is being called, our callback is being called, this will be also provided. Okay, this context will also be provided at that point of time. All right, now so there's a kind of example of API we're talking about, and all of these functions create, delete, exist, get, ACL, and set ACL, get children, get data, set data. All of this is provided in these two kind of formats. And watcher is that watcher which watches. So whenever, even in the sync call, we can provide the watchers. Watchers essentially, okay, the watchers essentially are triggered when something happens. Okay, so although we are saying that we are executing a command like exist, delete, along with that we can provide in even in the sync manner a watcher. Okay, and what does watcher does? Say for example, the watcher of exist gets notified when the node gets created, deleted, or its data gets updated. Okay, so we are check if we are providing a watch of exists for a certain node, then that watch will be launched. That watcher will be called whenever there is a node that gets created. If the node doesn't exist already, if the node gets deleted, then also watch will be mm, informed. And if node already exists and it is being updated, then also it will be watcher will be notified. All right. Similarly, get data can also provides you the watch that gets executed when either the node gets deleted or data gets changed. Get children also provides you the watch, and the watch will be launched or watch will be executed whenever the node gets deleted or any of its child is created or deleted. Okay, so whenever we are saying get children of a particular node, it will basically, so whenever get children we are executing on a particular node and you're providing a watch, the watch will get executed if the node get deleted or any of its child is created or deleted. All right. So access control list ACL determines who performs what operation, and there are multiple kinds of authentication it supports. One is digest. Digest means login and password. We can enable that login and password. And the other way of authenticating users for Zookeeper could be Kerberos. Kerberos is the general single sign-on kind of a mechanism provided by Unix and similar to Unix kind of systems. Now Windows also provide Kerberos. And the other non-secure one is that the IP address. So the IP address is okay if you are in a data center and you trust your data center, but it's not a great idea, right? So authentication based on IP address is not a great idea because if somebody compromised a machine, it compromised everything. All right. And so effectively an ACL access control list is a combination of authentication scheme. Okay. Authentication scheme, whether it's digest, SASSL, SASL or IP, and the identity for that scheme, as in who is the person we are talking about, and set of permissions. Okay. Set of permissions as in who can do what, can create, delete, and update a particular node or not. So the architecture of Zookeeper has, just like every other system, it's standalone and replicated. Standalone means that there will be no other node. Okay, there will be only one node which will be running everything. So Zookeeper is also a distributed service. And what does it mean by distributed? It runs on multiple computers simultaneously. But a standalone mode is good only for testing. The virtual machine that is provided generally for the demo purposes, they have standalone mode. Okay. The other mode is called replicated, and replicated runs on a cluster of machines, and we call this cluster of machines as ensemble, and it's highly available. HA means highly available, and it tolerates as long as there is a majority. I will. Do we have a reason why we have a majority? Okay, okay. So we'll talk about that one. So has anybody, any one of you learned MongoDB? No? Okay, okay. Let me just see what. Alright, don't worry. Okay. Alright. So Zookeeper, just like every other tool we have talked, is a heavily distributed service. Okay. Now, in case of our HDFS or our task tracker, job tracker, we designated nodes. We said you are name node and you are data node. That's not the case in Zookeeper. All right. Now, what happens in the Zookeeper? Zookeeper has got something called ensemble. In an ensemble, there are multiple machines. Let's say there are three machines, for example, right now. And all these machines have got something called a leader, and rest are called rest are called rest are called followers. Okay, so there is a leader and there are followers. This one we are talking about Zookeeper service. And interestingly, leader is not something we designate. Leader is something which they themselves designate among themselves. Okay, so we had a zookeeper service having three nodes. These three nodes will elect their own leader, and the quality of the leader is every write, whenever you have to write something, that write goes to the leader. Although the way we are connected right now to the zookeeper service, if every command which we are doing for writing is going to the leader, all right, and the leader propagates those changes. So the leader propagates those changes to all the followers. All right. And once it has propagated to the majority of followers, then it confirms back saying, I'm successfully able to propagate your changes. Okay. Whenever we said get, it 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 would hit a follower or it may hit the leader. Leader can provide both. It can provide read as well as write. Right? So from architecture perspective, this zookeeper service is exactly like a MongoDB architecture. All right. In MongoDB, do you have primary, secondary? Here there is a leader follower. Primary, secondary have the same election mechanism as the zookeeper service. All right. Now, so that means it's like heavily available. In case the leader goes down for a few seconds, somebody else will become the leader. All right. Somebody else will become the leader. Now, the condition for becoming a leader in a zookeeper service, because zookeeper, it's not physically possible for us to keep designating leaders and followers. Okay, it's not physically possible for the human to keep on doing it all the time for these services, and therefore the leader and follower kind of mechanism is quite strong, quite powerful, and quite useful. All right. Now there is a if. There is a if here. So who votes for who and how are the votes counted? So every follower actually votes. So every machine in this whole zookeeper assemble vote for each other. Okay. It's like in a class of 30 students. Every student is voting for all other 30 students. Okay. And the votes are based on the time it takes to ping a student. I mean, time it takes for me to reach you will decide how much vote I will give it to you. Okay. So, and in each ensemble, we give out for each ensemble, we in each ensemble, each node vote for other node based on the ping times. Okay. Which means if the other node is has given in past has a great track record of response, then that gets a higher votes. Okay. And effectively the and at the end of it, all of these nodes will speak out to each other who has got the highest votes, and then they decide that this particular node has got highest reachability to other nodes, and therefore that node should become the leader. Okay. So when a when a system is booting up, okay, when a system is booting up, the first thing that happens is the machines elect their distinguished member called leader. The others are termed as followers. The phase is finished when majority sync their state with the leader. Sync their state means they get the latest update from the leader. If the leader fails, the remaining machines hold an election within 200 milliseconds. Okay. So if the leader fails to provide the end user a response, or if other node pinged this leader and leader did not respond back, the other node will inform the all other nodes saying the leader has failed to respond and let's hold the election. And they hold the election. Okay. So leader is out and now there is a new leader. All right. And sometimes leader itself steps down, informing the other people that I'm stepping down. Somebody please take my position. Okay. So these are the incidents which trigger an election, and then the election of the distinguished member called leader happens. Okay. All the right requests are forwarded to the leader. I forgot to to mention this. The most important part in a leader selection. Most important part in the leader selection is the majority should vote for the leader. Okay, the majority should vote. If the majority cannot vote, that means there will be no leader selection. Okay, so in an ensemble of three, if two people are available for voting, it's good. But the moment there is only one person available for voting, no leader will be selected. No leader will be elected, not selected. Now, what do I mean by this statement? Let's have a look. Now, say you have five five members, five members. So how many members are required to vote? Okay. Qu- Quickly, three, right? Three. Good. And that means in case two computers, two nodes have shut down because of some problem, still there will be a leader and you will be able to write. The moment the moment three nodes go down, okay? The moment three nodes go down and we are left with two, there will be no leader. And zookeeper, you will not be able to write anything to the zookeeper, and zookeeper will tell you that there is no leader and hence we cannot proceed. Okay, your client will not be able to connect for writing. Do you think it is logical? If you had to design a similar service, will you do this way? Here, if three members went down, okay, and zookeeper is no longer available, anyone? Isn't the don't we think that although we have two computers available, let's continue with two? What's wrong with having only two computers to provide you the access? At least, I mean, we are not letting the user down. Why is it happening that way? Yeah, we shall make at least one as a leader. The normal logic says that out of two, just choose one leader and carry on, right? It's fine that three got down, but we are still left with two. Why don't we make one of the members as leader, right? Anybody? Why is it so? Let me pull out a slide because the changes I made do not are not visible here. So anybody can think of the reason why is it so till the time I pull out that slide. So my question to you is that, say there are six members, okay? There are six members in an ensemble. Three are dead, okay? Three are live and no leader. Is this acceptable to you? Because majority is not there. So it can at most tolerate the two members being down. So any idea why is it so? Because if I had to design it, if you had to design it, you will probably let these remaining three choose their leader and carry on, right? It's very important concept, and this is probably part of the gossip protocol, and it is one of the very important aspects of distributed computing. Okay, so pay attention, it's very important. Now imagine this. So I've pulled out this slide from MongoDB also uses exactly same mechanism, and I had made the same changes onto Zookeeper, but they haven't reflected yet. All right, now here you can see that there are three nodes, A, B, and C. All right, now A goes down, now we are left with B and C. So if A goes down, either B becomes the leader or C becomes the leader. Either of the two happens. Now, what if B as well as A both go down? Will C be the leader? Nobody will be the secondary, nobody will be the leader, and nobody will be the follower, right? Why is it so? Okay, that's a question because there is no majority. Majority out of three is two, and therefore there is no leader selection. Why is it so? Now think about this. Imagine you had two centers, data center 1 and data center 2, and you had an ensemble of six nodes. You had six computers, six nodes, who are supposed to elect their leader. Okay, so as long as there were six nodes available, there will be four nodes available for voting, there will be a leader. If there are less than four, in case three are available for the election, there will not be a leader. Okay, now imagine the other way. Let's say let's say in hypothetically it was possible, we designed a system in which no matter how many nodes are available for voting, as long as someone wins, make him the leader. Okay, right? So let's say we had A, B, C, D, E, F, G, and A is our leader here. Okay. Now the moment there is a wire disconnect between these two data center one, data center two. Okay. Now for these nodes of data center two, these nodes of the data center two, the leader has become inaccessible. The leader called A has become inaccessible, right? Which means that in case the which means these guys are supposed to start their election mechanism. And what if they did not need an they did not need majority? What will happen is they will have their leader, and this guy will the other data center will have their leader, right? Because we said it's okay to have even three to vote each for each other. All right, we don't need majority. So effectively, data center 1 and data center 2 both have their leaders, and hence there are two leaders now. Both of them are accepting the rights. So when a client connects, it could connect to the first data center or it could connect to the data center 2, and both of them are writing, and hence there is no consistency. half of the data is going into DEF and ABC. They're acting like they are two data two different ensemble altogether. Okay, so because there was a cable disconnect between these two, C and E got disconnected. Okay, I mean, not C and D. These data center 1 and data center 2, the wire that goes from data center 1 to data center 2 got disconnected. And therefore, the second data center also has elected their leader. And and this is exactly why you need majority. Okay. Now, in case this wire get disconnected in the current scenario in Zookeeper, it would not have any leader, neither on the data center 1 nor on the data center 2. Okay, make sense to you? Now imagine that A, B, C, and D all four existed on data center 1, while E and F existed on data center 2, right? And after that, this wire gets disconnected. Now data center 1 will have a leader, while data center 2 will not have any leader. Okay, because only data center 1, in that case, when all the four A, B, C, D, all four are on the data center 1, they will have the majority available for the voting. Okay, what if there are these are six in the same data center, right? So the reason I have taken the example, the reason this design of majority comes into picture is to avoid such kind of islands. Okay, so there has to be a central government, and to have the central government, it is essential that majority can only be in one segment. Majority cannot be in two segments. Okay, no matter how you cut or how you divide a piece of cake, majority, if we say that I want the more than half of the whole thing, then I will always be I will always have the biggest piece of cake, right? If I say that, hey, I always want bigger than half of the cake, right? No matter what others get, I will always get the biggest piece of cake. That is the biggest piece of cake possible. Okay, in the division. How do you know where the majority is in data center 1 or data center 2? So we will whenever the vote counting happens, all the candidates have voted for a leader, right? So the vote counting will happen. And in case the vote count is below 50%, nobody, no, I mean, those nodes will never become the leader. Okay, so effectively, when the vote counting happens and the less than 50% vote came in, nobody will become the leader. That's right, Rumen. So voting means every node every node will will form its opinion about the other nodes. Okay, and say that I'm voting for this, and inform that node that you got this much vote. And then uh, then in case the node that gets voted, okay, will, I mean, so how do you know where is the majority in data center 1 or data center 2? They both have three nodes. Okay, so we don't have to worry about whether there is two data centers, three data centers, or there is only single data center. We do not have to worry about that part. All we care about how many votes did we get. All right. So there could be a scenario that D and F and A have gone down. Okay. D and F and A have gone down. All right. Then also we are left with three nodes B and C and E. Right. In those scenario also, there will be nobody will be the leader. Okay. So the data center example I have taken because that is the concern, that is the reason why the uh, whole decision has been taken. All right. How, I mean, Riman, I hope I was able to. So as long as in this case with six nodes we have four nodes up, it is okay. Perfect. That's the point. So as long as say you can imagine that you can imagine that A or D went down. Now we have B, C, E, F. They will elect a leader. Now any one of them goes down, we cannot elect a leader. Okay. So just to avoid the various kinds of problems, yes, when we count, we do include the leader. All right. So sounds reasonable to you guys? All right. Any questions on the leader selection and the majority part? Okay. How is the case when a new computer is added? Okay. So any node that gets added will we'll just configure it such that we'll just inform one of the nodes that you have got a neighbor, you have got a sibling. Okay. And that is good enough. And that node will hand over all other information like who are the other nodes and also, uh, I mean, then the whole information gets propagated onto the ensemble. Okay. So we can keep on adding as many nodes as we want. And the moment we are getting adding more nodes, say we had three nodes, now we added one more, it became four, and then we added one more, it became five. And now the toleration limit has changed to two from one. Okay. When there were three nodes, we had a toleration limit of one, that in case one goes down, we can keep on having the leader still. And in case out of now we have added two more nodes, there'll be the toleration limit will be like two. Okay. Two node go down, we can still run happily. All right. Is that what you're looking for, Abhishek? Was that your question? So if you are adding a new computer, that adds to the again, when we are counting majority, that new node will be counted. So each added node accepts the pre-elected leader. Yes. Okay. So elections happen whenever there is a problem with the leader. Okay. Okay. And these mechanisms, the reason why elections are held, they keep on improving every now and then. Okay. Sometimes, I mean, I mean, whenever there is a response time goes beyond X limit, then the election happens. So those numbers keeps on improving across various versions. All right. Now, in the time of election, there is a outage or availability. Okay. So again, same thing. In case there is no majority during the election, okay, nobody will. Though say out of 5 nodes, there was outage on 2 nodes. 2 nodes are not able to connect. Then there will be a leader. If there are 3 nodes which are not available at that point of time, then there will not be a leader. So your point is that if there is a outage, and due to outage for that moment of time, the best candidate for the leader is not available at that point of time, right? And so we will be continuing. Hi. So you guys can hear me, right? Because it says to me that connection is lost. Okay. So so Abhishek, probably your question is that in case there was an outage during election, right? And and after that the availability is restored, right? So the point is, any system which is not available is not anyway suitable or the fit for becoming the leader, right? So in case your leader, no matter how great a computer it is, if it's not available, it's not a suitable candidate for becoming a leader, right? That is one thing. Now your next point is that other point was during this election does yeah. So during this election, the system is not available for 200 milliseconds. Though reads will be continuing, the system will get into the read-only mode if during the election period. All right. And that election period is around 200 to 300 milliseconds. Now, how do the writes propagate? All the writes go to are forwarded to the leader. Leader broadcasts the updates to the followers. I'm sorry. Yeah. So leader broadcasts the updates to all the followers who are following it. And when a majority have persisted the change, the leader commits the update and clients gets the response. The protocol for achieving consensus is atomic, like two-phase commit. Okay. Reaching to a consensus reaching to a consensus that I mean reaching to a consensus that the change has been persisted like a two is atomic. Okay. Also, all the machines write to the disk before in memory. Okay, that makes it permanent instead of writing to the memory and then going to the disk. Not the other way around. Because if you noticed, the way our other system write ahead log in case of HBase, there the data gets written to the memory first and then written to the disk. Similar is the case of the at various other places where you have the spillover to the disk. Okay, here it's the other way. Okay, it's a design decision because here the data is smaller. Okay, data is smaller. All right. So say a client is connected to a follower and client wants to write something. So the follower will internally redirect the request to the leader, and the client will now be talking to the leader instead. So in case where the moment client talked to the follower knew there is a leader, and in case during writing this leader failed, right? So client will get a failed request saying that your write request has failed, and immediately re-election will start happening. Okay, immediately a re-election will start. All right. Now there are few guarantees that Zookeeper provides, and these guarantees will guide you when you are deciding on which whether to use Zookeeper or not. Okay. It provides something called a sequential consistency. Okay. It provides something called a sequential consistency. Updates from any particular client are applied in the order. Okay, which means if there are two clients providing the updates to the leader, if there are two clients that are providing the updates to the leader in the order in which the leader receives the changes, it will have that kind of a consistency. That's called sequential consistency. Okay, so it will provide a guarantee that it provides a guarantee to the client that in whatever order the changes you make, those changes will be in that order, right? But there'll be other users also, those who might be making the changes, so that it makes that thing away. I mean, it does not, it gives the guarantee of the sequential consistency. Atomicity, either all the updates succeed or fail. Second, single system image. Okay. A client will see the same view of the system. The new servers will not accept the connection until it has caught up. So, so when say there was a node which became stale, okay, which became stale due to disconnection or some other problem. Now, if you try to ask that particular client, that particular follower, that hey, I want some data, it will not give you the data until it has caught up with the system. Okay, until it has caught up with its neighbors, that I'm on the most recent state of the data. Okay, so that makes sure that there's a single system image. Durability, as in as we told that the data gets written to the disk first and the memory, so there is always a guarantee of the durability, because only then the user is getting a confirmation. Only once the data gets written to the disk, only then the client is getting the reply, and therefore there is a guarantee of durability, right? Then there is a guarantee of timeliness. Now this is interesting. Rather than allowing a client to see very stale data, the server will shut down. Okay, it's quite suicidal. Okay, quite suicidal in terms of a client. If the client goes so much out of sync for a particular time, okay, which is configurable, then that machine will choose to shut down rather than provide any data. Okay, and that's the reason, if you'll notice that in case you shut down one of the I mean, sometimes the zookeeper automatically shut down, some of the nodes get shut down because if they go out of sync for quite some time, okay, they realize that they are isolated, And if they're isolated, people might connect to them and they try to read it. And in those cases, they choose to shut down by itself. Okay. All right. So few quick ones. So there is something called a session also in case, as you saw that client connected created an ephemeral node which disappeared the moment client disconnected, which means there is a something called sessions. The client created a session. Okay. So the client, when we say client is the library which is making you connect. Okay. You're connecting through the client. And if your program is connecting, then it will be connecting through the driver. So all the clients, whether it's command line or a library, they they gather the list of all the servers. You provide them entry point or maybe multiple servers. They connect to all the server, gather all this information that what all machines are there in an ensemble. And when you ask this client to connect you to Zookeeper, it will try all of the servers it has one by one and give you the connection. Okay. And every time you connect to the server, client connects to the server keeps a session for that particular client. And session has got a time period. So it's like those banking sites where you stay for some time and then you automatically get disconnected in case you don't do anything. In the similar manner, the client needs to keep sending the pings to the server in order to stay alive, in order to keep that session alive. Okay. And that is how the server knows that the client has disconnected. If the client does not respond within a time period, if the client does not ping within a time period, server assumes that client has disconnected and all the ephemeral nodes for that session from that client will disappear. Okay. Right? So client library takes care of the heartbeat. You don't have to program or do anything about it. Also, some of the failovers are actually handled by the client. When you try to use the client library and it fails to connect to a particular client, a particular server, it will connect to the another. So the failover, half of the failover is actually handled by the client library. Okay. And in case client is connected to the server and that particular server went down. Okay. Now when this client will shift automatically to another server in the ensemble, and in case there was of course there will be a session created for the first session for first server. The same session will also be valid in the new case, because client command line tries its best to keep keep the user on the same page. Okay. Client automatically reconnects to any other machine. Client maintains, I mean, if it's connecting to the another machines, the server session will be maintained and so on. Okay. So the failover is beautifully handled by the client also. Though when you are coding such an application which is connecting to the server, you also need to keep in mind that there would be a chance that the client will fail. Okay. There is a chance that client might fail because it is in the intermediate state. All right. So it was trying to connect to all the servers, but nothing worked out. In those cases, you might get an error. Okay. Or while it's trying to reconnect, If you try to do some operation, it will give an error. Make sense to you? All right. So what is the point? What's the point of having zookeeper in place? Now imagine this. Imagine this. You are a e-commerce company who has multiple servers, and there are lots of clients, API clients. Okay. They connect to your servers. They connect to your servers. So what happens then? So you have got hundreds of servers. You have got a zookeeper library, zookeeper kind of ensemble, and there is a army of clients who will be connecting to these servers. There will be an army of clients who will be connecting to these servers. Now, how do these clients know that which servers are available? Either you put an admin who will keep on updating the list saying these are the servers which are available, these are the servers which are available, or you build some your script which will keep on pinging all the servers in the in the system and keep on updating its list. Also, then you will have to have a hard coded list of computers. Whenever we are adding a new one, you'll have to update this list, right? That is quite clumsy, and you cannot provide a high availability with this manual intervention. Therefore, that's where zookeeper comes in. So all these machines, all these desktops, or whatever you want to call them, all these clients, they would connect to the zookeeper, okay, and then see which servers are available. Okay. And how does they do that? All these servers, when they come alive, what they will basically connect to Zookeeper and create an ephemeral node for each of their IP addresses. So each of the ephemeral node contains the IP address of each of these servers. When the client connects, they'll ask Zookeeper ls/servers, and they will see that these are the IP addresses available. In case one of the servers goes down and disconnects, that ephemeral node will disappear, and when the client does a dir or does a ls onto that server's node, it will not see that the IP addresses which had got disconnected, right? So that is the one use case of having zookeeper in place. And HBase example we have already seen anyway, right? So this system you can actually see by yourself. So let's say that how many, so we have got one, and we have got two, and we've got three, and let's say we have got four. Okay. All right. Now let's say I have got these four windows over here, and in all of them, let me just, so those who are new to Unix, if you press Control R and then type few letters, you will be able to search in your history of the command prompt. Okay. All right. So so here there is something called slash server list. Okay. So let's say there is a node called server list under which any client that connects. So I'm connecting all these people. All right. All right. So now there are four people connected to the servers. Yeah. Actually, we can connect to not only Hadoop 1, we can connect to Hadoop 2, Hadoop 3, Hadoop 4, and run Zookeeper client. That will work out pretty well without any problems. Okay. Now we have got slash server list. Right now it's empty. Okay. Now so the first server, this window. Okay. This guy comes in and says create an ephemeral node at server list with something like cow or its IP address 202.111.134 something like this. Okay. Sorry. Create minus e and then I say server list slash, is it server list? Yeah, server list slash I say 1.1.1.1. Okay, and with some value. Okay, now the first one, when it sees that there is one server awake, and now it can this is, imagine that first one is the client and rest three windows are that of server. All right, now it says, oh, there is one server available now. Similarly similarly the second client, this one comes to life and says I am second. Okay, then third one comes alive and says I am third. Now you can see that we just created three servers. Now the client will see that oh, there are three servers available, and now the moment the first one disconnects, okay, the first one disconnects. After some time, this will disappear. After some time, this will disappear. So it'll take few seconds to disappear. All right. So that's exactly the of role of of Zookeeper when it comes to load balancing or when it comes to making your system highly available. Okay. So most of this complication of connections is handled by them. All right. So you do not have to implement that leader, and so if you are a web developer and you want to make your system really highly available, so you do not have to implement all of that what do you call gossip protocol, or all of that selection mechanism so that your systems become highly available. All you need to do is, on all these machines during boot up time, you just connect to the Zookeeper via library, and that's all. Okay. And while connecting to the Zookeeper, all you need to do is inform that my IP address is this much. That's all. Okay. Now your 90% of your distributed programming problem of making your node highly available is solved. So now let's see, has so this one has disappeared now, the first one. the second and third are still available. Okay. If you disconnect the other ones also, they will also disappear. All right. Now, few things you need to do is you need to you need to emulate these two slides which I gave you here by yourself. Create your own parent node, and under that node you do whatever you want to do, and you try to do all of this. Okay, try to take these steps, and quizzes would be coming during week where you will get an email that you there is a quiz. Okay, and you check out that one. I'll be sending an email saying that the quiz is available, and try to finish the other quiz also. And other than that, emulate this scenario by yourself. Okay, it's not very difficult. Okay, but it will make you quite confident in dealing with Zookeeper. Okay, the more use cases, it's up to you how you can use a whiteboard or how you can use a similar kind of coordination service. Okay, so few of examples is building a reliable configuration service. Configuration service means that we generally have a central configuration which is distributed to all the nodes in the across the systems. So generally whenever we apply like a singleton pattern, if you guys are from any Java background and or from all patterns and all, so wherever you try to build a singleton pattern where your data is available across the application in a single node system. So the way we always used to do is when we have to make some data available across all the functions, all the libraries in our J2EE application, we used to make that a singleton. Okay, but in case of a web, that's not something great because you will have multiple computers and static variables do not make any sense. Okay, static variables are very specific to one particular computer, and therefore static variables should be avoided in case you are writing something which goes beyond one server. So in case your J2E application has static variables and you have two machines running the same J2E and there is a load balancer which is shifting the load which is coming from the user sometimes to the first one, sometimes to the second one, your static variables will not serve the purpose. They will actually corrupt the data. Okay, okay. So on those cases where you have something like a configuration service or a distributed log service, all of those make a great candidate for Zookeeper. All right. So that's pretty much with respect to Zookeeper. And after the break, we will carry on with Flume and Scoop. All right. We'll continue with Flume and Scoop after the break. So so I'll be back by 8:46 IST. Okay. Hi guys, I'm back. Are you guys back? Should we start? All right. Guys, so should we start or? All right, all right. So I'm trying to see that. All right. So actually, I'm trying to see what is going on with my Hive service. All right. So we are going to talk about Scoop. Scoop is essentially an open source tool that extracts data from structured data source such as a database. In very simple word, you can think of Scoop as the bridge between Hadoop and RDBMS. And when we say Hadoop, it means we can import export data to and from HDFS, Hive, and HBase using Scoop. Okay. So if you want to move your relational data into into the uh, mm, into HDFS, if you want to move your data into HDFS as a file, like CSV file, tab separate file, or any other format file, then also you will use Scoop. In case you want to move your data from relational database into Hive table, then also you will use Scoop. And also, if you want to move your data from from your any relational database to HBase, then also you will use, and vice versa. All right. Now, in case in case you're trying to move the data from a source which is not there listed yet, you can implement uh, a connector using the extension framework provided by the Scoop. All right. Now, all you need to do is, as right now, uh, you can SSH to any of these servers. Let me disconnect my Zookeeper. Okay. All right. So now we have only one node connected, and I'm connected to Hadoop one. You can connect to anyone, and it should work. Okay. So Scoop help should show you the help listed in here. It provides you import, export, and all those uh, parameters. And right. So here, right. So where all I mean, from which all databases can you import the data to Scoop, or from which to which all databases you can export data using Scoop is is driven by something called connectors. Okay, so the available connectors as of now is anything that supports JDBC. Okay, MySQL, Postgres, Oracle, SQL Server, DB2, and generic JDBC connector. So, which essentially means that almost all the databases are covered in Scoop. Scoop can actually work on almost all the databases. All right, because almost all databases have JDBC driver. JDBC is the Java database connectivity. I mean, Java database connectivity suite, which is basically implemented by almost all the database vendors. All right. Now, as an example of my SQL minus U root, so now say for the example purpose, so I'll be going through taking you through an example of MySQL. So you do not have to run this command because MySQL is already running. Okay, MySQL is already running. Show databases. Hmm. All right, let me see what goes on with. All right, now here, actually, what should I be doing instead is. So before I start, let me just create a couple of tables. And here, what I'm trying to do is basically let create a database, a fresh database, create a table, put data into it. That's what I'm trying to do in this. All right. So I logged in. Let's just create. All right. Now create data scoop ex3 and give all sorts of permissions on this. So we gave the permission to scoop 3 from all the hosts like this, and let me also grant permission to All right. Now, so I created the database. I gave various kinds of permissions, and now I'm creating a table called widgets with widget name, pricing, design date. Where is the typo? Can you tell me? Ouch. Ouch. And that's a fatal typo. Thank you. So I think only Abhishek is paying attention. Okay. All right. So now let's see. So what I'm trying to do is, because this database is going to be used by other servers, let's just see MySQL. All right. So let's just try to connect Hadoop one, no big data. .com. MySQL management help. And for MySQL, what is the way to provide server name? MySQL. Server arg embedded server parameter minus piece password prompt no pager host host host. All right. So this is connected. Is it created now? Good. So I'm able to connect. All right. Thank you, Harish. Yeah, that was the right one. And so I'm trying to see if I am able to connect from all the nodes. And I say select star from widgets. Now you can see there is a data. So this is sample data which we want to import into our HDFS. All right. Good, good. So we are able to successfully connect from another node, and we will try to understand how will that work. Okay, now we have created this sample table called widgets. In this widget, these are the data which we have already put. Now we want to move this data onto our SDFS first. So we'll go in we will take two approaches. First one is multi-step process, and then we'll do it in a single step. Okay. So here, if we have to import this data, so we tell Scoop that Scoop import connect to my JDBC, and my table name is this, and there is only one number of reducers we want. Okay, so let me just get out of MySQL. Now it says Scoop import connect to MySQL on the local host, and we need to understand that how do we provide the login password in case of Scoop. Okay, we want to understand Scoop man's help. All right, so help import. There are too many options. Okay, connect this connection manager, Hadoop home, password is empty minus username. This is the one. All right, so what we are trying to do, sorry, this should be, there is a mistake here. It has to be ex3 because ex3 is the one we have been working on. This the database name we are talking about, ex3, and username root, and password is blank. It doesn't allow the blank password. It doesn't allow the blank password. Oh, password is actually the empty one. Alright, so the proper command is this. Alright, now it's trying to do something. And what is it trying to do here? It'll take the data from our database. From this table widgets, it will create a file in this folder. Okay, let's see, is it giving some sort of error or is it creating something? Let's go to our hue. It says connection refused. Driver has not received any packet from the server. And why does it do that? Okay, import failed. All right, no worries, let's debug it. And also please note that here whenever I'm trying to import, if you see, it's trying to basically create MapReduce job. Okay, writing jar file and then running all the MapReduce tasks you can see here. So why does it do the MapReduce? Because your data might be big and it can utilize the data nodes, various data nodes, to fetch the data from your database parallelly and make it really efficient and faster, right? And that is probably one of the reasons why would you like to use Scoop and not your custom program, okay? Because this is far more efficient than your custom program. It runs as a map reducer and does it parallelly on all the nodes. So let me first delete the file. It says the output directory already exists. Okay, it says output directory called widgets already exists. So it will say Hadoop minus fs move fs to old. All right, let me just run it again. Okay, just a second. Let me try to do a few more changes and see what goes on. Hadoop 1 dot no because no big data.com, because this is to connect from all the mappers, right? And mappers will run on multiple computers, so it makes sense to use Hadoop 1 dot no big data instead of using localhost. Okay, and minus minus username root minus minus password. What does it say? The driver has not received any packet. So what does it mean? Driver has not received any packet. Oh, again typo. Okay. So this time nobody is paying attention probably. So okay, just to bring you in the context, what I'm trying to do is I'm trying to run this command of scoop, which connects to my database, okay, which connects to my scoop 3, and import this table widgets into the file system. Okay, what does it mean by importing the file system? In the hdfs we should see at the end of it a folder called widgets. Here here we will see a folder called widgets. All right, right now it's not there, or maybe it's on another page. Alright. Now it is doing something, or it has done something, and yeah, it has successfully done it. All right, it has successfully created the file. Now let's have a look at this file. You can see part M. So that shows you that it is done by using MapReduce, and this is the output of your reducer. All right. Now you can see that. So our data is successfully imported. Are you with me, Abhishek? All right. All right. Good. Good. So so we have this file already created now. Yes. Yes. Please go ahead. Yeah. You should create your own database for sample table. All right. And this presentation is anyway shared with you. Now, Done. So also notice that here in the same folder in which we ran the import, you will see a file called widgets. Okay, so this is a good this is basically auto generated file, and basically object relational mapping for our table, and we can use this in future in our Java code in order to repeat this process again and again. Okay, in order to repeat this process again and again. So where is our command? This is our command. All right, now let me just take this command and put it in the presentation. Now, next step is, just now what we did was we took our database table, put it as a CSV onto HDFS. Okay. The next step is that we create a Hive table. We create a Hive table out of it. Just a second. So Hive table has to be from Hadoop 1 dot nobigdata.com, and again we'll have table here ex3, and we also need to understand the way of providing the login password. All right, help. Yes. Yeah, so syntax is same. Good. Syntax of providing username password is same. All right, now let's create. Good. So what exactly are we trying to do? First, we created a comma separated file. We created a comma separated file into our HDFS. Now, next step, if you remember, was to create a table in the Hive, right? To create a table into Hive. So, instead of we doing it ourselves, we are letting Scoop create a table into Hive. If you remember, we did in Hive when we were learning Hive, what we did was we created a table, imported data into that table, right? We imported data into the table. That was the second step. So first we created a table. That's what we are trying to do. Instead of we ourselves typing out all the commands saying create table widgets and my column name is this, value is this, column name is this, data type is this, and all that, we are letting Scoop read the definition from MySQL and create identical table into Hive. Okay. So what it did was it basically created a Hive table, right? Now let's just check if it is created Hive and select star from Hive widgets. So let's drop this table, drop widgets, and then do it again because it has already created. It was already there before we even tried to do anything. Okay. All right. Now Select star from select star from uh, widgets. Now it's empty. And describe formatted widgets. It's created. Good, good. So we are good. Now the next step is that we import our data. We load this file which we created earlier, load data in the path called widgets into our table which we have just now created. Okay, so we set this. Now if you see, we have got widgets table and it has got the data. All right, so sounds good. So we wanted to move our data to Hive. So we did it in two steps. First, we moved our data to HDFS and then created a table in Hive and then loaded this data from HDFS into Hive. Ideally, we should have done it in a single step, just for illustration, or maybe in the future use where you want the HDFS file to be separate. In those cases, you would go for this approach. Otherwise, you will just go for this kind of approach where you can say Hadoop 1 dot no big data and all right, now you have got this. So you can actually do the same thing in a single step. Let me drop the table. Drop table widgets and I'll get out of the shell and run it. So output directory called widgets already exists. So let's just drop it. Hadoop fs minus rmr widgets. You can say rmr or you can say rm minus r for deleting a directory. All right, now just starting to read the data from there. It's doing something. Good, good. So now you can see that the data has been imported probably. Let's just see. We had dropped the table, remember? And you can see the statistics. Right now it has only created one map task. And on which node is it running it? Oh, it's on the Hadoop one only. That's the task. Okay. No, actually, Hadoop 2 is the timeline service. Okay, all right. Now select star from widgets and good. So our data has been imported successfully. Sounds good to you? So this is a single step process where we say scoop import and this is our connection URL and this is the table which we are trying to import. And then we also specify number of reduce phases you want, number of mappers we want actually. I think it is that mapper. Let me just check. So scoop help, scoop help import. It's a number of mappers, not reduces. Okay, it's a number of mappers. All right, sounds good to you? Because here mappers are not ready, decided by HDFS. Mappers you have to decide because it has to read the data from MySQL. Had it been reading the data from HDFS, based on number of blocks, it could have decided how many mappers are going to be. All right. Therefore, there is an option to customize number of mappers. All right. So sounds good to you? Okay. So what should be the strategy for deciding number of mappers? Good point. So you generally decide number of mappers based on what kind of how much load can your MySQL take. Okay, is your MySQL load overloaded? Then a single node will do, single mapper will do. Because in case your MySQL is already under the load and you ran Hadoop with say 20 mappers, so 20 Hadoop nodes will be connecting MySQL and taking the data out from MySQL. Okay, so be cautious when you decide number of mappers more than one. All right. Now the other way around. In case you want to import, not other way around. In case you want to import the same table which we just did for our example, we want to import this table into our HBase. All right. So what we do is we say connect JDBC and same table widgets table into an HBase table called my HBase table. Let's first check if we have. So can somebody tell me how what's a command prompt? A command for launching HBase quickly. I want to connect to HBase. What is the command line for connecting to the console of HBase? Yes. Good. Good. So first one is HBase shell. HBase shell. Good, Malik. And let's check. What do we do to check whether my HBase table exists or not? My HBase table exists or not in the HBase? Yes. I want to know in the HBase. So what is the command to see the tables? What's the command to see the tables? Malik? How do we see all the tables existing in HBase? Anybody else? Yep. So show table, not show tables, it's list, right? So already there is a table called, okay, table called. So let's just disable my HBase table and then delete my HBase table list. All right, now we have deleted our old table, and so that when we run this command, it should not be there. All right. Now again, we need to specify the login password. All right. So what we are saying is import this database and this table into HBase my HBase table and create everything into this column family. You can customize this part by specifying multiple columns of this column family, and this is a username and that is a password. So what does it say? It's not able to connect, could not find HBase table. This the job, either explicitly create the table or rerun with HBase. Okay, let's just ask. What it's saying is either you create the table or rerun it in with this argument. Okay, we will rerun it with this argument instead of creating the table. Right? Sounds good. Okay, so yeah, the the quote actually creates a lot of trouble. I don't like these quotes. So what we're trying to do, we are trying to import the data from MySQL to HBase. Earlier with the scoop, we did an import to Hive, and now we are trying to import to HBase. That's correct, Anna. That's very correct. Any questions on this? And any questions on why we are doing this? So it's a brief demo where I'm trying to demonstrate the import process. So import process now successful, and same thing could be done for a humongous data as well. No, scoop is for, okay. Scoop is basically distributed way of importing data into our Hadoop. Okay, that's the challenge. Scoop is not for streaming. All right. Now let's check if we were able to do it correctly, and we say HBase shell. I assume scoop is streaming. No. Any challenges with the big data? Yeah. The challenges basically are because the data is huge, so you can utilize the multiple servers bandwidth to read the data. Okay. So scan my HBase table, and when we say HBase table, it essentially means, so you can see that the table has been created. And what do we have in the table? We have row IDs. These row IDs are automatically assigned. We did not do much about it, or did we? Yeah, these IDs have been automatically created. Okay, and right. So this data has been imported. We created a column family C. It created a column family C1, and it added the columns, their values with the timestamp. Right. Is this tool for people who want to move from RDBMS to big data? Yes. Or vice versa. So this import is only for the tables, not the entire database. Okay. And here we are not moving the relationships of foreign key, private key relationships, or any kind of a constraints onto the database. All we are doing is moving the rudimentary information such as column, their data types, and columns, number of columns, and the data to the database. Okay. Unlike the standard import export tool where the whole thing, the constraints, the everything goes with to the another database when we are trying to import. That's not the case here because constraints do not exist in any of the big data, any of Hive or HBase. All right. So we were able to successfully import the data. Okay. We were able to successfully import the data and into our HBase. Now the next step is the inverse of what we did just now. Okay. Inverse of what we did just now. we create a we create a table in Hive, and then we import that table back to MySQL. All right. So let's just create a file called sales log and cat. So we call it, all right. So we have, right. Now let me just delete the last line. So in case you guys are not comfortable with VI on the Unix servers for editing file, you can also use either Pico or Nano. Nano should be there. Nano is a good editor. You could use that one. Okay. So you can use Nano also. Right? These are minor little things which would help you. Now let me just go into Hive and create a sales table. Table already exists. So let me just drop table sales and right. Now let me also copy the database first. No, actually you can directly do that. Okay, copy local from load local, because we are using local in path here, right? So it has started loading. Now we can see the select star from sales. Good. So we are able to import the data into Hive quickly. We are able to import the data into Hive quickly. And the next step is to create a MySQL table. Note that here we have to create the table by ourselves. So we are going to MySQL, and the password for this root is use, let's say, default, or let's say scoopx. Use scoop ex3, the database which we created earlier, right? So we have created the table. Now the next step is, so what we are trying to do, we are trying to export the data from Hive to MySQL. Before that, what we did was we created a plain text file, load and created a Hive table, loaded this plain text file into Hive. Okay, we loaded this plain text file into Hive, and then we loaded this basically after the next step, we created a table in MySQL. Now we are trying to move the data from Hive into the MySQL. Okay, from Hive to MySQL, right? So other alternative to Scoop in market, there would be other alternatives, but let me just do a little research on this. Yeah, table has to exist in the MySQL before exporting, because let me see if scoop export help export here, connect connection manager driver Hadoop home Hadoop this relaxed isolation. Yeah, I think you need to create it by default. All right, and what do we need to do? We need to tell, okay. Now let me just have a look at what were the login password. Same one. Good. All right. Let me. So what we're trying to do, export the data from scoop ex3, not 2, using a single mapper from a table called sales in the Hive, and the directory is, this Hive table will be created over there in scoop 3. Okay, and the directory is the one where our data is located. By default, if you do not provide a location in Hive, it automatically creates in the warehouse. That's what we are referring to. Okay. Now, That's it. All right. So we say scoop export my database information, whatever the URL and which table we want to export to. Then the file which contains my Hive data, and Hive data is by default created in the warehouse folder under apps Hive, and our input fields are separated by comma, and username is this and password is that for MySQL. Okay, so it was successfully imported. It was successfully imported. Okay, now let's go to MySQL minus u root and minus p. Okay, we say select star from select star from okay, select star from sales, right? Use scoop ex3, select star from sales. Good, so it's working fine. So okay, so password is blank. Okay, here you can see username is root and password is blank. Okay, just make sure you do not create any table which has a permission to access from outside, and probably we will also set a password for MySQL. But right now it's okay because we are only allowing our MySQL tables to be accessed from within our own network. Does the table have to? Okay, okay, great. So everybody happy with the export? All right. Now this was for the structured data. This was for the structured data. Now the same thing you can also export from HBase into the MySQL and whatnot. All right. Great. Now the next tool which we are going to discuss is Flume. Flume essentially makes it possible to push the non-structured data. Non-structured data, what does it mean? We do not know the structure upfront. Okay, so Flume choose to provide you any custom format you want for your import export, for your movement of data. Okay, so say for example, you have got lot of Apache logs and you want to move those into the HDFS. And these Apache logs are coming from hundreds of servers. So you are running a fleet of Apache servers and you want to move all of the logs from all of these Apache servers running on the fleet onto your HDFS. And you want it to happen every day or as and when it happens. Your Apache logs should keep flowing to a central location. That's a common way of doing things, right? Second thing is, say you are downloading data from various unstructured sources. Maybe you are downloading Twitter data, okay? That all can happen using Flume. You can download data using Flume from Twitter, and then using Flume itself, you can push that data to HDFS. Okay, it's a common way of doing it now. So that's exactly what Flume is made for. It's basically a distributed, reliable, and available system for efficiently collecting and aggregating and moving large records of data, okay, from many different sources to a centralized store, right? So people from the general architecture is like this. So there is something called a source, there is something called a sink and there is something called a channel. Source produces the data, channel and sink consumes the data, and channel connects source to the sink. Okay, source could be the web server's entry point, web server Apache's logs entry point, and sink could be leading to HDFS. Okay, source is essentially connecting some data producer to the channel, and sink is essentially connecting the output of a channel to an HDFS, right? So, and you can keep on chaining all of these together, right? You could have channels output might be going to multiple sinks, channel might be accepting the data from multiple sources, and you could have instead of HDFS you could have another channel further moving on. So using this strategy of source, sink and channel, you can actually make really complex flows and really powerful flows. All right, so we'll take up an example of how do you do this, right? So Flume is, so the sources could be your Apache log, and it allows you to define sources like tail minus f. Who can tell me quickly what does it mean by tail minus f? What does it mean by tail minus f? Are you with me? Reading last line of file. Okay. So Abhishek, in case you have done tail minus f, what will get printed right now? Okay. So question is that, say we have done tail minus f and then file, and then the file updates. So does your output also changes, or it just exits? If tail minus f on a file, it just prints last files and then exits, or it waits for new changes? I mean, is Ajit saying the right thing? Wait on a file, print as it updates. Okay, so basically the tail minus f is the standard Unix way of seeing the logs. So if you are running a server and you are doing some testing, you leave one terminal open with tail minus f. And as and when you're doing stuff, this terminal will keep on printing what's going on with that log. All right. So tail minus f is exactly made for that. And as Ajit said that wait for file, print as it updates. Good, right? So there could be multiple kinds of sources. Sources is something which produces data, and then there is channel. There is channel, source, and sink. Source could be examples of sources: tail minus f, syslog. Syslog is Unix way of storing all the logs, and log4j. Those people who are from Java background, they can correlate that log4j is basically uh, a generic way of Java logging. So any logs coming from Java application, J2E application, they can also be the source for the source in the Flume, right? Now, Flume nodes can be arranged in arbitrary topologies, and I was when we talk about topologies, it means we can make a network of these things. Okay, each channel can output to multiple sources and vice versa. Okay, so that builds up a really resilient and very reliable way of transporting the data from one place. Typically what you do is you run one Flume agent on all the nodes that are generating the data. And I mean, there are is running on each of the machines which are generating data or receiving data, and you connect these things together, and the data keeps on flowing till your sync. Okay, the ultimate sync will put the data into either HDFS or into local file, or somewhere it can be persisted, right? So you could have, I mean, using these topologies, you could have two kinds of ways. Okay, okay. So the Flume is essentially helps you move unstructured data from various sources to your HDFS or other places. So Flume is a data export import for for unstructured data. Anna? So you could create the topologies which do not tolerate any node failures and gives you the best effort delivery quickly. And then you could also build the topology which guarantee the delivery in node failure. Okay, which guarantee the delivery even if there are node failures. Okay, now let's have a look at it. So here what we are going to do is you can actually you can download this file by yourself. But before that, I would like to explain to you that we are going to create we are going to create a sink. Okay, we are going to create a topology where our data is coming from netstat to basically HDFS. We want to, okay, objective is listen to a port, and whatever is received. Okay, so so port is our, say, so we want to build this. Okay, we want to build a service which listens onto a particular port and pushes the data onto HDFS. Okay, in syslog, for example, in Unix, syslog is a network daemon which keeps running in the network. All the services connect to syslog and deliver their logs to syslog via a network connection, right? So so this is what we want to build. Okay, we want to build a service right now which accepts all the network connections and moves the data onto HDFS. All right, so the good way of doing it is you create this config file create this config file. All right, you can actually download this whole project. So I'll describe the config file later. So in simple way, we ask Flume to take this config file and do the job. Okay, what it will do is it will create an service which will be running on a port 444444. Okay, now you can connect to the 444 and keep on writing to it, and that will you will find the data located somewhere in the HDFS, right? So the our services are connecting to this port and delivering their logs, and that logs is getting transported automatically to HDFS. That is one use case we are trying to build. All right, so we'll take it up in the next session. Till then, you can also give it a try. Okay, it's a full project. Okay. All right, let me just finish it up. No, actually, all I need to do is copy this, save it to a file, and save it to basically a folder, and then we say that this is my config file. Let me just go to my folder and then, right. All right. So I've saved it already and I'm trying to run it. It says that the specified configuration file does not exist. And so which means I'll have to define it like this: conf/flume. So now we have successfully created a server at this, and whenever we are going to, where is our file? Asgiri flume web data. Asgiri, Asgiri flume. Where is my folder? Here, right? So I'll just show you one little output, and then rest of the things we will do it in the next session. Web data, where do you see the web data? It's not there. Okay, good. So Asgiri flume, all right, here, right? So these are the probably the old file, previous one. Let me just delete it. Right now, right. So we are running a service on this port from another terminal. We are connecting to Hadoop one dot nobigdata.com, and let me just disconnect it because that is running on 127, which is loopback, which means only the local machines can connect to that port. Okay, if we give the public IP, our IP, then other nodes will be able to connect. Right now, let me say telnet. What am I doing? I'm trying to connect to this service and speaking to that service using a generic way. So I'm writing to it, and as a consequence, you will see the data being created over here. You can see the data got created just now, and this data is in a binary format provided by the Flume standard. Okay, so I'm just typing this stuff, and this is being written over here. Sounds good? Sounds good. All right. So basically, the data is continuously moving. In case you can effectively run any of the log services using this mechanism very neatly, right? So CU is a byte format. Yeah, this format is actually something which Flume directs. Using the Flume's standard, you can use deserialize it, and then you can see that. All right. Or maybe we can configure somewhere that keep it plain text. Here, if we can just specify somewhere. Okay. Flume data plain text. Great. So see you on the next Saturday, and we will continue our discussion from this point onwards. We'll go into the details of Uzi, and we will run through a recommendation example. Okay. We'll run through a recommendation example end to end, and so that you are ready for taking up the full project. All right. Thank you guys. Thank you very much. So yeah. So for those who are in India, for them it will be Saturday, Sunday morning, the same time, no different, same time as it was this weekend. All right. And for in the people in the US, it would be probably in the evening on Friday and Saturday, right? Friday and Saturday. Yeah. All right. I hope you guys are enjoying it. Whatever I'm trying to explain. In case you are not, just let me know what are the things I could make changes to, and what are the changes you expect, and I will most likely will try to change it. Yeah. So let me make a plan. I will make a plan and let you know about the Java class. Okay. And stay active on the forum. Try to answer the questions asked by other people. Even if you can add on to something which we have answered or other candidates have answered, it will be great. Okay. It will be great. Thank you guys. It was a great time. And in the meantime, you try to do all of these examples. You should actually run Flume by yourself. Okay. You should actually run Flume by yourself. Flume, one import example. Just do whatever I did. Okay. Even if you are just mimicking it, you will understand everything. Okay. Theory is easy. I mean, theory is good. You will be able to score pretty good in objective questions. But when it comes to the doing it, it it forces you to do a lot of things. Say, for example, you had to edit a file. How do you do the editing of the file, right? Then you realize, oh, I can use Nano, right? All right. And one more thing, just keep all the chat logs saved. In Windows, you by default have the chat logs. And after the 11th class, whosoever is on Windows, please send me the chat logs, these all chat logs, so that I will upload it onto your LMS and make it available to all of you. Because on Mac, it doesn't save the chat log. It's a known problem for them. And I'm on the Mac, right? GoToMeeting stores the chat log at some place on the disk. Okay. All right, then have a good day. And for those who have evening, have a good evening. And see you later. Right? Bye bye. See you guys. Bye bye. Have a great week ahead. Reach out to me if you have any doubts. And